Hello, my dears. Good morning to all of you. In this session, we are going to take up circles. So, it's a very, very important chapter as far as the board exam is concerned. It is a simple chapter as well. If you learn all the concepts and understand it in a better way, then circles would be very easy for you. I have given a lot of interesting conceptual notes for you guys to understand. Let's keep it rolling. Hello, my dears. In this session, we are going to see circles. Very simple chapter. If you understand the concepts better, it will be very, very simple. So please understand this video very carefully. I have explained you nicely, and so I'm going to explain you nicely. Sorry, I'm going to explain you in a very nice way, and let us go to the session. So here you have introduction and followed by some useful theorems and then useful PSTs. PSTs, problem solving techniques, I have given at the end. So it would be useful for you. So here you have a circle AB. It AB is a line segment. See this line segment here in this, it touches your circle at two different points. So anything which touches your circle at two different points, any line that touches your circle at two different points, you call it as a secant. And here you have another line segment which touches a circle at only one point. Anything which touches a circle at only one point, you call it as a tangent. And you can construct infinite tangents to a circle. Please remember this, you can construct infinite tangents to the circle. So a circle can have two parallel tangents at the most. At most two parallel tangents. See here, this is PQ, and if you draw another tangent RS, RS in this direction, so you can have at most, you have two parallel tangents. Please remember this. They will be asking all these things in your MCQs. So a circle can have two parallel tangents at the most, and you can construct infinite tangents for a circle. So a circle can have infinite tangents. So you have to know the difference between these two things. A circle can have infinite tangents, but they have given you a condition. At the most, you can have only two parallel tangents. So whenever they give you the condition, you have to be very careful while answering. Just if they ask you how many tangents can a circle have, then straightforward answer. Answer is infinite. So at any point on the circle, there can be only one tangent. So you have a point A, so you can draw only one tangent uh, through this, that is PQ. So next is, so these are the basics of circles. Next is the theorems, two very important theorems. First is tangent is perpendicular to the radius at the point of contact. I have proved you in a very simple way. So xy here is the tangent and OP and OQ are the radius. So see carefully, xy is a tangent, OP is the radius. So now you have to prove OP is perpendicular to xy at the point of contact P. Point of contact means the point where the tangent and the radius intersects. So the point where the tangent and the radius intersects is P. So OP is perpendicular to XY. This is what you have to prove. So see here, extend OP. So this is an extended line. So that's why I have drawn this dotted line to make you understand better. Extend PO to OQ such that PQ is the diameter. Now you can see that PQ is the diameter because a diameter should always pass through the center of the circle. O here is the center. So PQ here is a diameter because it passes through the center of the circle. And you can draw another line, horizontal line over here, so that this portion, the upper part of the portion is a semicircle. And know, you know very well that angle in a semicircle is 90 degree. Proof. Angle in a semicircle is 90 degree. So that means this OP should be perpendicular to XY. This is the simplest proof. Hope you guys have understood it well. So same way you can write it in your exam and you will be given full marks. So this is a more simpler method to solve this question. Next, you have another very, very important theorem. Lengths of the tangents drawn from an external point to a circle are equal. So what is the tangent here? Where there are two tangents here, PA and PB. P is the external point to a circle because it doesn't lie on the circle. You can see here P lies outside the circle. It is an external point. So you have two tangents that can be drawn from an external point to a circle. PA and PB, both of them should be equal. That's what you are asked to prove. Lengths of the tangents drawn from an external point to a circle are equal. So for this very simple proof to take, you first join this OP, and you have two triangles OAP and OBP. So carefully see in both these triangles PAO, PAO and OA meanwhile is the radius and PA is the tangent. We have now seen from the first theorem that the tangent is perpendicular to the radius. So PAO angle should be 90. Similarly, PBO should also be 90 because PB is the tangent and OB is the radius. So PAO should be equal to PBO. Both of them should be 90 degree as per theorem 1. So you should not write theorem 1, you should write the theorem in your exam. And next is OA equal to OB because both of them are the radii of the same circle. So OA equal to OB because both of them are radii of the same circle, and you have a common side in both these things, which is OP. So in these things, if you see, these two triangles are congruent because as per SAS rule of congruency, side angle side rule of congruency, you can say that, or also you can tell that it is RHS because RHS comes for a right angle triangle. So this angle we saw that it is 90 degrees. So you can say that it is RHS or SAS, whatever. So triangle OAP is congruent to triangle OBP, and then now you apply CPCT, which is corresponding parts of congruent triangles. You can say that PA equal to PB. That's it. Very simple proof. And next is some useful problem solving techniques I have given, and I have also given hints how to solve. These kind of questions can be asked in your exam. They will be asking you to prove these theorems. So tangents drawn at the ends of the diameter of a circle or parallel. This type of questions you can see it from your NCERT book. I have given you the hint how to solve. Tangents drawn at the ends of a diameter of a circle or parallel. You have to draw the diagram, and then you can prove it by using alternate angle theorem. Alternate angles property. Using alternate angles you can prove. You have to apply the first theorem also, and then using alternate angles you can prove it easily. And next is perpendicular at the point of contact to a tangent to a circle passes through the center. So please see this carefully. Perpendicular at the point of contact. Perpendicular at the point of contact to a tangent to the circle passes through the center. So we'll go to this again. Perpendicular to the point of contact to the tangent passes through the center. So you can write the same proof. You can write the same proof as we did for proving theorem 10.1. The first theorem. So since it is there in the 10th chapter, I have put 10.1 by the way. So xy is a tangent and PO is the radius. So here if you extend this, you get PQ as a diameter because it passes through the center, and angle in a semicircle is 90. Same proof, you can use it for proving this property. Okay, next is a very important, very important question. Prove that parallelogram circumscribing a circle is a rhombus. Circumscribing a circle, so you have to draw a parallelogram. Inside the parallelogram, you have to draw a circle. So that is circle inside a parallelogram, and use the second theorem. That is tangents drawn from an external point to a circle are equal. So and then you will have 4 different equations. So you have to add all the left hand side and the right hand side individually, and then you have to simplify by using the properties of parallelogram which you already know. And then if you do that, you get this thing, that is you will get everything as equal. So you get a rhombus, AB equal to BC, somewhat you will be getting. So that means it should be a rhombus. Last thing, last part, two tangents. This is also an NCERT question. So two tangents TP and TQ are drawn to a circle and T is the external point. You are asked to prove this. So for proving this, you need to apply the first theorem and the second theorem, applications of both the theorems, and then you have to apply angle sum property. Angle sum property in a triangle. So angle sum property in a triangle if you apply, and by application of these two theorems, you will be getting this answer. So with this, circles chapter is over. Hope this video was useful for all of you, and wish you guys the best. Now let's meet in our next video. Thank you.